Hello everyone, this is the video lecture for Pre-Calculus section 6.5, Law of Sines. So sines means like, sine x or whatever we're doing. It's, sine, cosine, tangent kind of stuff. So law of sines is very important. It's basically the formulas that we'll be using to solve any triangle possible. Normally what we've been doing up till now is that it had to be a right triangle in order to solve, and we use sine, cosine, and tangent. Not here. You could use it still, that's fine, but this goes for any kind of triangle. It could be some kind of triangle that looks like this, or any kind of triangle can be solved using these formulas. So first off, we got sine of capital A over little a. Now notice the capital A, that's an angle, and that's a side. So these are angles, and that's sides, okay? Is equal to sine of B over B is equal to sine C over C. Notice my capital C, I got a little thing on the top of it. That's just, I'm trying to differentiate it between, because they kind of look the same. And so I'm going to try to do that for my capitals. And so you can see I kind of drew a picture over here of what's going on. I got my angle A. The opposite side is little a. Again, with B and B, C and C, the opposites there. So given that you have a couple of this pieces of information and this cool formula, of course, I'm hoping you might remember some of this from like geometry class. A plus B plus C, all the angles on the inside of a triangle add up to 180. If you don't remember it, well, there you go. Anyways, with these two formulas, we should be able to solve any kind of triangle problem. Okay. And notice that they're all equal. That means that you can do A and B together, you can do A and C together, you can do B and C together, whatever you got to do, just in order for you to get this thing done. Okay. Let's do it. Let's start with a 65005. Here we go. So I've got here a triangle. My triangles are not going to be perfect, okay? I'm just going to do the best I can here. I got 52 degrees. I've got here a 70 degrees, so that's definitely not to scale. I have a 26.7, and then I've got an X. And they say, go, figure it out. Well, this is A, this is B, and this is C. There you go. All right. How am I supposed to solve for X? Well, I'm going to start writing out at least some kind of formula that I know. Well, here's something. I got sine of A, that's 52 degrees, right, over X, right? X is little a, basically. It's the opposite there. That should be equal to sine of the 70 degrees over B, my little b right here. I don't know what that is, but whatever. And then I got sine of C, which I don't know, divided by the 26.7. Again, that's little c down here, because it's opposite. So I'm missing a lot of stuff. Like here, I'm missing the X. That's what I'm trying to solve for. Here, I'm missing B. They didn't say nothing about B. And here, I'm missing the capital C. So I want to use one of these guys, but I'm missing all the components. I don't know how to get started, basically. Well, notice that's why we have this other formula. It helps us out. If there's that last little bit of information that we need, I need to find C. Well, my C is going to be equal to 180 minus the 52 minus the 70. And so putting those together, I got, what did I get? I got 58. 58 degrees. So that's a 58 right here. And so I don't know what little b is, but I do know what C is now. So this guy is kind of like complete. This guy is what I'm looking for. So let me use those two. I'm not going to use the B in this case. Oh, sorry. So then let's do it here. So I'm going to rewrite it. I got sine of the 52 degrees divided by X is equal to sine of the 58 degrees divided by the 26.7. So again, I wrote it all out like you see up here on purpose so that you can see I'm just trying. I'm like stumbling about, trying to figure out what to do next. And that's okay. I think that as I keep going, I'm going to actually do it, more targeted. I'll just show you how to go about it. But if you're confused about which formula to use or what side, and that's, initially it's going to happen, just write them all out and see what you're missing. Can you find something like, can I find B somehow? And like I'm looking around, I don't know. I don't have a formula for B. Do I have a formula for the C? And I would say, oh yeah, I do. It's that 180 rule. It's the 180 rule. So then once I got that, now look, I only have one unknown, right? The thing I'm actually looking for, and we can start solving. Okay. So that's my thoughts. I'm not going to do that every time, but that's the point. Okay. So to get x by itself, I'm going to multiply it over here. Okay. But at the same time, I'm going to take all of this and divide it. This is a very common thing that I'll be doing throughout this section. I think I would do it once or twice in every single problem. So I'm multiplying this up to the numerator, and I'm taking all this into the denominator. And so I'm just going to write it straight up what exactly has done. It's like big division here, okay? And I even use parentheses sometimes just so I don't, confuse myself. Notice all of that. All of this is in the denominator, and now x is in the numerator. I guess, divide by 1 doesn't really matter. He's in the numerator. See how I brought all of this down there? This is all one big number. I don't know what that number is, but it's all down there. Well, like we solved for x. Ta-da, we're done. And I want to say that I'm going to put all this into the calculator at once, and my answer is 24.8097. They're going to want about 4 decimals, maybe 6 or so. I can't really remember exactly what they want for each problem, but I'm going to go out some decimals on each problem. Now, if you're not getting this number, then I want to show you, write it out, what it looks like in the calculator, because this is a lot, you know what I mean? So, and this is like a TI or a Casio or whatever, as long as you can see all the display at once. So I got the sine of 52 degrees. You wouldn't put the degree symbol. You would just be in degree mode. Let me just say degree mode, since we've been doing that a lot. So sine 52 divided by, open parentheses for the entire denominator. Okay, so I got sine of the 58, close, and then divide by the 26.7, and then close for denominator. Notice my denominators all together. I think that's it, and you just get that. So again, I'm not going to slow down so much for this every time. The idea is that you kind of see what I'm doing here, so that on the next problem, you just kind of copy-paste it, because there's a lot of copy-paste in this section. But that's okay. That's okay. It's good training. So here's another one. So they give me some kind of random triangle thing. Again, I'm just doing the best I can. I got an 8, and here I got 69 degrees. And then this is an A, this is a C, and that's a B. What they're looking for is little a, angle A, with a degree symbol there, and angle B. Now, I can't remember what WebAssign always has. I did this a while ago, my notes, and I think that's a good thing. I don't want to go too far, and I want to call it cheating. I don't want to give you everything, but I often put this little angle symbol next to it. This is what I have in my notes. I can't remember if it's there all the time or not in WebAssign, but we know the capitals are angles and the lower cases are sides. They're like clearly showing that these are angles with the degree symbols or capitals, little angle symbols. I don't know. I might not put the angle symbols every time, but that's what that is if you haven't seen that in a while. It's like a little angle symbol. Moving on. So I'm wanting to find the unknowns. I want to find this guy, and, well, I guess this is little a. They didn't really say that, but, we know that because it's opposite that guy. So those are the 3 unknowns that I need to find. And I'm kind of lost. I don't know where to go from here. And so we could start writing it out, I guess. Like, let's do something with B and C. I think those are the best things that I have. So, like, okay, I got sine of B over B is equal to sine of C over C. Why did I choose these two instead of A? Like, why did I not choose an A instead of whatever? Well, notice that I don't know anything about A. Does that make sense? These 2 A's right here, they're completely unknown to me, both of them. But, like, if I had a big list, do I have little b? Well, yeah, it's right there. Do I have little c? Yeah, it's right there. You can see that I have these guys, so B is in C's I got. But I don't have anything related to A, so we'll come back to A later. B's and C's are at least something I got. I got something there. So let me start filling this one out then, okay? So sine of the b over little b is 8 is equal to sine of the c. I know c is 69. And then all over, again, 8. What's kind of interesting is that these 8s right here, they cancel one another. That does not always occur. I'm just literally saying, multiply by 8 on both sides, and they somehow cancel. Well, you got sine of this equals sine of that, and the sines cancel, and we get 69 degrees for B. So you can just go ahead and put that in the answer there. Well, you kind of probably already guessed, knowing that these two are the same length, that this is an isosceles triangle. Don't even ask me to spell it, but it's 69 degrees here and here. A more common isosceles is something like this, where these are the same angles, and therefore these are the same sides, okay? While this would be a different side, and this would be a different angle. So we're looking at an isosceles triangle. It's just kind of tilted a little bit. Okay, so we did that so far. Great, good job. Now what do I do for A? Because still I have no clue what A would be here. Well, again, if I started writing it out, I'm not going to do this every time. I keep saying I won't, but I'm just trying to make sure that you're okay with this. Let's just use B, I guess. I don't know. That's fine. B or C. Either one's fine right now. So I want to start setting this up. I'm missing 2 of these variables. There's no way I can even solve because I need only 1 missing variable each time. Do you see what I mean? I need 1 variable unknown, and then I can go and solve for that. Well, this sine stuff is just not working for me. I'm lost. What do? Well, like we've done before, the 180 rule. It's kind of like a backup. I would say if you're lost, confused, or not understanding what's going on, use the 180 rule. I'm just going to write the 180 rule. And so let's do it here. I got my A would then be the 180 minus the B, which is 69, minus the C, which is another 69. And I got my A to be a 42. Okay? In fact, that's actually one of my answers. There you go, 42. Cool. So, again, it's not the first thing I do often. I mean, I could have probably done it the first time, but it's a good backup. Okay, now that I got that, I can actually use this, I believe, because sine of A, I know A is 42. Little a, I do not know yet. Sine of B, I know B, it's 69 degrees, right? And then divided by 8 still. I need to solve for little a. See, 1 unknown, so I can actually figure this out. I'm going to multiply this to this side and take all this and divide it over here, just like we did on the last problem. It's a very, very, very common thing to do. And that's why I don't want to actually show every single multiply and divide step. I'm just saying, move it over, get an answer. 5.733887. There we go. Cool. Moving on, next one. 65016. So I got this longer kind of triangle. That'll work. Notice that this right here, this angle is obtuse. Obtuse means more than 90 degrees, so this is 95 in this particular. It's not. It doesn't look like that. Nothing's to scale here, but you know it's close enough. 26 degrees. They say that this distance here is a 420. We got an A, we got a B, and we got this as C over here. Okay. All right. What they're looking for in this case is little b, little c, and then capital C. And then a little degree symbol, I suppose. Okay. Again, you can put the little angle symbol if you want. Whatever. Okay. So how do I start this problem? Honestly, I'm looking ahead, and I'm seeing that we have 2 angles already. Couldn't I find the third now? Couldn't I use the 180 rule immediately? So my C angle is equal to the 180 minus the 26 minus the 95. These are all degrees. And I found it to be 59 degrees. So I'm going to put a 59 in there right now. There's one of my answers. Look, I didn't even have to do much. I just did the 180 rule, and that was really good. I'm sorry for this being so silly looking with the little hat. It has a little hat on him. But it definitely differentiates between little c and big C, okay? So I got to keep doing it. So little c is down over here, and little b is over here, and this is my little a, because, you know, he's opposite of that. So what should I use now? Honestly, you can use any pair that you want, because as long as it has the a in there somehow, because a is one of those knowns, so that we can solve for the other unknowns. Let's do a, of course. We got the 26, sine of a over little a equals. And let's do b, I guess. We'll just do b now. So b is 95, and little b I don't know. Okay. So to solve for b, multiply it over, divide all that stuff. I mean, we've seen this quite a few times already, and this is, you're going to see it every single time now. Not that it's bad, just a quicker technique. Okay, good. Put it all together, and I got 954.4464. Okay. And to solve for little c, I'm going to do it all over again. Now, this is kind of an interesting thing. I got a, b, and c to use. I'm going to pick a and c. See how I did a and b? Now I'm going to do a and c. My c angle was the 59. And little c I don't know. Why am I using a again? Couldn't I use b and c together? Technically, yes. In theory. But as far as like WebAssign and rounding answers, I would say no. The reason why is because if you were to use this right here, this is my a's, right? If I were to use b's here instead, I would have to use this answer here. Notice that it's a decimal. And it keeps going. I just didn't write them all. Obviously, it goes on forever pretty much. So can you write out enough so that you won't round incorrectly? Like, what if they're asking for like 4 decimal places? Then you're going to have to go not 4 over here. You're going to have to go like 8. I would say at least. Given that these signs here are going to change so many decimals, I would be very, very scared to use one of my already found answers, if that makes sense. So I'm going to say stick to the originals. Stick to using the original numbers as much as possible. Okay? There might be a time when you have to go and use a long decimal. I believe there might be something kind of up later like that, and that's fine. Occasionally we have to do it because there's no other option. But if you can, at all, use what they've been given to you. And look, it's easier. It's integers. So I know that I had to say that. You know, it's just part of my job here. So multiply by the c, divide. So I got 59. I got the 26. And then I got the 420 again. I mean, if you go back and look for a second, look right here. Compare this right here. Compare this. Compare those two. Look at that. I mean, basically the denominator is exactly the same. You're just changing this number here. Don't think like 59, 95. Oh, there's a pattern. No. Don't think like that. That's not what I'm trying to say. I'm saying look at my denominator. They're the same. Look, sine of an angle, sine of an angle. Is that a formula? Yes. I can't remember it. I always go back to the original law of sines formula, but I mean, if you really like this sort of formula pre-made something or other, that's fine. I mean, I'm not against that. Okay, I rounded to 4 decimals, so there we go. There's my answers. 65023. So I've got B. I'm going to try to write that a little bit better. B is equal to 24. C is equal to 30. And angle B is equal to 26 degrees. Don't know why I'm doing angles on each one of those. Whatever. This is an interesting problem. You know, I'm not going to do every single problem with you for you, but I do want to talk about this one because this problem has 2 sets of answers. 2 sets of answers. Can I show you? So I got my A is equal to blank degrees, C is equal to blank degrees, and little a is equal to some side. And then they just repeat it. So like instead of just the 3 boxes like normal, we've got 6, and they're like repeating it. So I'm kind of like confused. They also have a little bit of words saying, oh, this side used this angle, or this side used the bigger or smaller angle. Honestly, I can't remember exactly which way it is, and it might change. So just what I'm trying to get at when I get to this problem is I got to think about this problem differently than what the other problems were like. I got 2 sets of answers, and somehow I'm supposed to make this thing work. Let's analyze what we have here, okay? So knowing that we have the 2 sets of answers, I'm going to show you what it is, and then I'm going to start filling these guys in, okay? So this is what I see when I say 2 sets of answers. This is what I see. I see some kind of a triangle. Again, forgive me for not making it perfect here. That looks kind of like this. That's going to be the best I can probably do. Notice that we have this angle here is fixed. That's a fixed angle. Okay, but I actually have 2 different triangles that are possible. So like, I guess this side is fixed, this side is fixed, but notice that they're the same size, right? If you're wanting to do like a physical understanding what's going on, is that this is kind of like pivoting on here, like a big circle, okay? And this radius is touching this straight line right here twice. Touching right there and right there, making 2 possible triangles. I have this guy here, which would be my obtuse answer. So he's obtuse for this guy. I'm just going to do this to kind of remind us that we still have another one there. And then the other one, it looks kind of like this. Again, the other angle's like right around there. But this is my acute answer, okay? Acute. So I got my acute answer for whatever that is, and I got my obtuse answer for whatever that is. This is a very, very particular question. And I would say in the past, like say when we had like paper tests and all this kind of stuff, they would simply present this to you here, and they wouldn't tell you about the 2 sets of answers. They wouldn't tell you nothing. They just say solve. Solve. And you'd have to go through a set of evaluators, kind of like a formula that would tell you that, oh, this is a problem with the 2 sets of answers, given this kind of stuff here. Notice that we have like side angle, and so that's a particular thing. If you have a side angle, then blah 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 to test it if it's this way or that. We're not focused on that anymore. Okay, I know that the book will have this. If you want to go to the book, that's fine. But WebAssign, remember, we're using WebAssign for homework, quiz, and exam, right? So WebAssign always will present this 2 sets of answers. They have to. Technically, think of it like a computer. They can't just give you 1 set of answers and expect 2 of them. I mean, unless somehow they're going to change the program on me, I don't know. But as far as I remember and seen, it's always 2 sets of answers, very clear. So when you see this format, this is what you do. That's what I'm trying to get at. Okay? Back in the day, we might have to do more formulas. I would have taught that. That's fine. I don't see that now. If it comes back up, I don't mind making a correction to this video, but I'm just going to keep going, okay? So I'm assuming this thing right here, okay? Keep that in mind as I keep going. So given that I have these fixed angles here, and that fixed radius, and then this fixed side, 2 fixed sides, and this angle right there, let's redraw this, okay? Again, I'm not going to make it perfect. I'm going to try my hardest here, okay? That's pretty close. Okay, so if you go back up and scroll up to the question, B, C, and B. So this is definitely my B angle right here at 26, for sure, okay? That means that this side over here is little b, 24. So this is a 24, and this is a 24. That's like a little isosceles triangle in there. C is this one that's constant beside B. Now, you might be thinking, well, how do I know that it's this one and not that one? Well, this guy changes. Notice that we have this distance for one of them, and we got this distance for the other. And so this is a changing answer, but they give us one. They gave us one answer, so it's fixed. So this must be it, because this doesn't change. This side doesn't ever change here. And so that would be my C, which is at 30. And so Notice that if this was B over here, this must be my A, and these guys here are going to be my C angles, these guys, okay? I guess there's two of them. You can do that, I guess. And so this is going to be little a right here. This is one of those little a's, but the other one here is the other little a. Okay, so we got two different little a's. We got two little angle a's. Got two c's. Lots of stuff going on, okay? All right. So how do I even start this problem? I'm going to break this down into two different triangles, like you saw me do earlier. If you're thinking, man, you're spending a lot of time on this problem, I am. It's an important question, and it's going to come up not only in this section, but also in the next. That's close enough. Trying to draw a little triangle action. So I got 26 right here, for sure. I got a 30 right here, and this guy's a 24, and I need to solve for the missing answers. So, let's start here with our C. That's one thing I would start over there. On this side, the same thing. We have over here a 26. Let me just do this to remind me. We got a 26. We got a 30. And this is a 24. And again, this right here is my angle C. Okay. So I don't know which one I'm going to actually get first, but I do need to start solving. And I'm going to start solving for angle C. Okay, notice because I've got both B's, right? I got big B, little b, okay? But I have a little c, so I need to find that last c, okay? So I'm just going to start with one of my formulas here. Sine of b over b is equal to sine of c over c. Let's fill in what we have. So sine of b, that's a 26, over little b is a 24, again for both of them. Okay, I'm just following, I guess you could say I'm following directions, right here. I'm just filling in the answers from this guy. I don't even care about the triangles right now. Sine of c, I don't know what c is, and then little c is a 30. Okay, so let's start solving for little c. I'm going to multiply this to the other side, and that's almost it. I got sine of c is now equal to 30, and he's in the numerator now, times sine 26, all divided by 24, okay? Now, you can go and get this in the calculator right now if you like. That's fine. But what I'm going to do is the arc sine of this to get the most exact answer. So how do I get rid of the sine? I move it to the other side with an arc sine. Arc sine. Like sine inverse, I guess you can say. So arc sine, sine inverse of this. Again, you could do some decimals along the way, but you better be careful with retaining as much decimal as possible. If you round too much early on, then your later answers could be wrong, but your first answers are right. How many times have I seen that when people ask my teacher, and they say, hey, I got 2 of these right, but the third one is off all the time. I don't know what I'm doing. Wrong. What am I doing wrong? Because it'll say, there's 3 boxes, right? And it'll be like, check, check, X. And you did, you're right. You double-checked everything. You got something right. The reason why is rounding. It's always, always rounding. So, you can ask me. I'll tell you it's rounding. I could see the answers when you do that. When you send it to me, I can look at it and say, oh, yeah, it's rounding. You're off by 1 decimal place. And so you don't want that to happen. Obviously, you don't want to go through that process. I'm telling you, don't round. Don't round. Just keep every decimal that you can. Go out 10 decimals if you can. Or just put it all in at once so you don't have to deal with decimals at all. And so what I got here was the 33.2274 degrees, okay? Now, this is one of my answers. It truly is. This is my C, okay? My C angle. But the thing is that I don't know which one it goes into. Remember, we have 2 sets of answers. This is acute, isn't it? It's less than 90. So what we're actually dealing with on this guy is this one right here. This is this answer here. Okay, we're talking about that triangle. Okay, cool. Well, how do I get this guy over here? Kind of interesting question. So what I do to find, actually, you know what? No, I'm not going to go that route yet. Let's just keep going on this triangle. We'll come back to this guy in a minute, okay? So I got my C, cool. Now I need to find my A, right? A is one of those things I need to find, and then little a. Just focus entirely on this guy. We'll come back to this dude in a minute, okay? Let's just focus right here for a little bit. Well, how do we get A? Well, we got B, we got C. We can find A with the 180 rule. 180 minus my original angle of 26 and minus the 33.2274. Again, notice I'm using a rounded answer. That's bad, but I have to. I don't have another option at this point. So go as many decimal places as you can. Now, I know that I'm only using the 4 right here, but you know what I'm really probably doing behind the scenes is I'm using all of them, or I'm using the answer button in the calculator. Have y'all seen that? It's like near the bottom, I think. So anyways, you press the answer key, the answer button, and it comes up with the longest decimal possible. It retains that decimal as much as possible. Do that, okay? Don't rely on rounded answers always. Okay, so we found our A. Cool. So we got 2 of our answers already. Now we just need to find little a. So I got sine of my A. Again, notice I'm having to use this rounded answer. It's pretty tough. Over little a is equal to sine of. Should I use B or C here? Well, notice that C is rounded. I don't want to have to keep using rounded answers, so I'm going to use my B's here instead. B's were fixed. B's are simple. I mean, look. 26. 24 was the other one. Little b. Like, do you want to write out a long decimal every time? No. You want to use the simplest, shortest answers possible. It's another benefit to doing this. So A's and B's. To solve for little a, I'm going to multiply it over here. Take all this, divide it. See, we're doing the same thing again. So I got the sine of the 120, 7726. Again, I'm only doing 4 decimals here because of, like, demonstration purposes. I'm trying to let the calculator retain all those as much as possible. Okay, put it all in the calculator once, and I got 47.0398. And again, that's a side. That's like a units. So we're done. We got done with this one here. Boom, we're done. We got it all. We're solved it. So what about this guy now? So if you remember your answer for C, this is going to be a pretty important number here. Let's go back and understand this. The difference between my C's is that this little guy here, this is my original C at 2274, right? And these are isosceles. Remember that that's 24 and 24, right? Again, this is my full triangle's this guy. I'm just showing you this portion of it, okay? Well, I want this angle right here. I could find this one on the inside here, this little guy right there. What is that? Well, it's the same as this one because they're isosceles. They're both 33.2274, both of them, okay? So then my real question then is, how do I get this guy? Knowing that I have all this, how do I get that one? Well, notice that this is a straight line, and I'm just kind of dividing it. This is the 33.2274. So what's this guy on this side? That's a 180 degrees right here. Can you see the 180 degrees that we went? And so, in a way, I'm saying I wouldn't say the 180 rule, but we are using 180 to find this other angle here. So I'm going to do 180 minus the 33.2274. And so what I got here was the 146.7726. And that's my C for the bigger one. Notice that this guy is obtuse. So yes, are we actually doing this guy now here? See, it's obtuse right there. Yes. So that's our new one. This is an answer. There it is. But do you see how I've used a decimal answer to go and find this guy? And now I'm going to be using the same decimal answer again. I'm telling you, write as many decimals as possible. I'm using 4. Maybe I should have used 6 just for demonstration purposes. I don't know. Just be careful, please. Be careful. So we got our angle C now, and I want to solve the rest of that triangle. Remember that this is the obtuse one. So we got here is the 146.7726, This was always our, what was that angle? 26 degrees. This is 24 length, and this guy was a 30. So what I need to find here now is my A and then little a down over here. These are my unknowns. How do I find little a? I'm sorry, how do I find big A? My angle A. Well, the 180 rule. A is equal to 180 minus my B is 26 minus my C is 146.7726. So I got 7.2274. Okay, cool. So that's a small little angle up there. So we got our answers there. And then finally, I can find little a by doing sine of A over little a is equal to sine of, again, B is probably the most accurate over little b. Same thing as last time. Multiply, divide. We've already done this a lot. Okay. This was a very long problem, but as you know, I was talking about it a lot. If you were to go back and do another problem like this, I wouldn't talk nearly as much about it. I would just do it. So there's a lot of teaching moments in here, you know. This is 6.88773. So that's a unit, so that's a side. I have one last final note on this particular problem, is that you need to make sure you put them on the correct side. Notice that you got 3 boxes here, you got 3 boxes here, and I can't remember, but there's going to be words like, oh, blah, 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 blah. Put the obtuse or the acute on this side or that side, or the bigger angle for B, or the bigger angle for C, or da-da-da. I can't remember the words. I don't even care. But make sure that you're putting them in the right place. If you get everything all the way wrong, just flip them and see what happens. I don't know. So, like, you know, if this right here was the 6.88 and it said you were wrong, oh, then try it over here, and maybe that'll work. I don't know. Just be careful to read the words. It might change. I can't remember. So we got more problems. Let's keep going. And, of course, if you have any questions on any of this, just let me know. I would say this is one of the more confusing sections out of our book, out of our class, honestly. So I am exaggerating this triangle for sure, okay? But the point is I think it's a word problem. Either it has to do with radio towers or satellites or planes. There's all kind of different lighthouse. There's all kind of stuff in this section. I can't remember it all, but I do know that they have a triangle set up for me. That's a 84.2, and this here is an 87. Again, I'm exaggerating the heck out of this thing. 80s are so close to 90, it's crazy. It's like near vertical. So they're both looking at this thing almost straight up in the air, and there's 70 miles between these two things. Okay. And they're wanting a couple things from this. They want the height above the ground. I can't remember. This might be a plane or something. So, like, let's just say it's a plane. They want the height of the plane above the ground, and then they want the distance of the plane to the station. I think these are stations or something. A and B. I can't remember. Oh, yeah, it actually is A and B. Okay, good. I have it written down there. Okay. So I need to find little h and little b. That's my goal now. Okay. How do I do that? So, there's actually a lot to, take in here. The h will come much later. Let's not focus on h right now. Could I find all of my angles on the inside maybe, or at least another one? Notice that that's 87, so what's this guy right here going to be? Well, that's going to be a 180 minus the 87. Should make 93 degrees, okay? So this is technically going to be my real A. I mean, they have it pictured as the 87 this way, but this is my real A, okay? When you're actually solving this, you ignore that guy. After you've done the math, ignore it, okay? That's one of those common mistakes that I've seen with people saying, like, if this is on a quiz or something, let's say, they would use that same number too often. You have to go back and just redraw the triangle this way now, okay? So brand new triangle. Here's 93. Over here is the 84.2. and then we have 70 right here. So how do I keep solving? Well, I can actually find this angle up here using the 180 rule, right? So this was C, let's say. So I got my C is equal to 180 minus the 93 minus the 84.2. And so my angle C ended up being 2.8 degrees. Notice very tiny. That's why this is super exaggerated. I'm just, and this is not even an answer. This is cool and all. It's not one of my answers, but we're going to be using it here in a second. So I got this guy now is the 2.8. Notice that 2.8 is opposite of the 70, though. So that's pretty cool. So let's do sine of the 2.8 divided by the 70. Okay, so that's my C's. And we want B, so let's do B's. So sine of B would be the 84.2 divided by little b. My little b's don't look very good. I'm trying to make them sharp at the bottom, like a little pointed. Multiply by b, divide by all the stuff. Again, we've done this a lot. So this should be very common and easy for you at this point. Sorry. Decimal points are really hard with this tablet that I'm drawing with. Just saying. Put it all in, and I got 1425.629. That must be a satellite. That's not a plane, I don't think. Cool. All right. So we got that amount. That's actually part A or whatever. Well, how do I go back and find that height now? Notice that if I redraw this little height area here, this is my height, this is my B, and this was the 80, what was it, 87 degrees? 87 degrees. Now, go back up for a second. All I'm doing is taking this triangle right here, this little one. Again, on the WebAssign, it's like super thin, but that's the idea. I want just this guy here. Could I, and notice it's a 90 degrees right here. That's pretty interesting, actually, isn't it? And I know what B is now. It's the 1425.629. Could I use these with like a plain old sine, cosine, or tangent, just old school stuff, back from the last sections? Well, I would say yes. I'm going to use sine. Sine of the 87 degrees should be opposite over hypotenuse. Okay, this is way old school stuff. Again, remember this is opposite over hypotenuse. So we're using stuff from the previous sections here, and that's fine. I'm going to take this guy, multiply him to the other side. So my h is now equal to 1425.629 times the sine of 87. Put it all in the calculator, and I got... I did something else actually on my paper. I wonder if I get the same answer. Okay, hold on. Let me use my calculator. I did a different style for solving for part B on my notes. I mean, I looked this over before I started, and I mean, that's cool. If I get this one wrong, then I'll go back and fix it, I guess. Sorry. But I'm pretty sure this is all I have to do. Yeah, I got the same answer. Okay, yeah, we're good. We're good. Just making sure. I'll tell you what I did. I don't like what I did, actually. I like what I did here in front of you just now. This is much better. This is miles, I'm pretty sure. So, okay. What I did is I solved for A. So I solved for A over here and then thought of this as one really big triangle. So I was using this angle. And I did the same process, but instead of using this triangle here, I was using the big one. But I had to solve for A to do that, and that was a whole other step. I think that's silly. I got the same answer, so whatever. Don't do that. Do this. This is much easier. Okay, cool. One last problem. So 65033. I have, let me try to draw this correctly. That'll work. So I got an 82. This is my A. I have a B, which is 52. That's a 52. I got X right up here. Apparently is 300. This is a word problem. It must be something maybe about a river or something else. I don't know. So I got little b, and I got a capital C, and they want to find what little b is equal to. This is super easy stuff. It's more so, I would say, interpreting the word problem for what they're wanting. I got two angles. I got a distance between them. What's the distance for this guy here? Well, sine of b over b is equal to... well, I need to use this 300 somehow. What if I go and get this guy right here first? So on the side, real quick, 180 rule. You can see it's kind of impromptu, just kind of like jumping in and getting it. I got a 46, so I'm going to use that over here in my answer. So sine of the c. Oh, I should use just c right now. Look, you can see I'm using a formula. Okay, there we go. So let's fill it in now. Sine over c over c. Okay, so we got the 52. I got little b, which I'm trying to find. Here I got the 46. And then I got the 300 is opposite of that guy. Okay. So again, why didn't I use A? Because like, I guess I don't know it. I don't know A, capital A or little a. Well, actually I do know little a or capital A. I don't know. Maybe because I would have had to solve this one and then go back and solve for the X. I don't know. Just do the quicker way that you can find. This is quicker. And you can see that like I had to go and do a little bit of math to be able to get it. That's fine. So here we go. B is equal to sine of the 52 degrees, all divided by this stuff. And then the 300. I got 328.639, and that's in feet. Okay, awesome. Well, that's it. That was a big section. So thank you very much. Have a great day.